Hello friends, next topic we will discuss today is IP address classes. Well, in the last lecture we have discussed about the IPv4, that is the Internet Protocol version 4, and we also know that IPv4 is also called as the IP, Internet Protocol. Why? Because IPv4 is the default IP, so you don't have to specify every time that this is the IPv4. So IP address or the IPv4 address is divided into particular classes, that is the 5 types: class A, B, C, D and E. This is also called as the classful addressing. So in the classful addressing or IP address classes, we divide the IPv4 addresses into 5 types. So these are the classes A, B, C, D and E. Now the classful addressing is of two types. The first one is binary notation and second one is decimal dotted notation. So first is my binary notation and second one is my dotted decimal notation. So firstly we will start with the classful addressing of binary notation. So first of all we will discuss the binary notation of IPv4 addresses. So we will draw a table. Now, in the binary notation, we have the 5 classes and we have discussed the classful addressings of 5 types. So, first classes are class A, in which we have all the 4 octants. So, in this class, as we have the particular IP address, which is having the 4 bytes, that means the IP address is the combination of 32 bits or maybe the 4 bytes. So, this is my first byte, this one is my second byte, then my third byte, then fourth byte. The next one is my class B, next one is our class C, next one class D, and lastly we have the class E. So now these are the 5 particular classes, class A, B, C, D and E, in which we have divided our IPv4 addressing. Now as we are discussing about the binary notation, in the binary notation we will discuss about the 0 and 1. So whenever the first byte of any of the IP address will start with 0, that is called the IP of class A. If the binary IP starts with 10, that represents the class B. If it starts with 110, then that means it is of class C. And if the IP is of class D, that means that must start with 1110. And if the IP address is of class E, that means it will start with 4 times 1. So these are the representation of binary notation of IP address classes. So now come to the decimal dotted notation of classful addressing. So now we'll discuss the dotted decimal notation of the IPv4 addresses. This is the part of classful addresses. It is again divided into 5 parts: A, B, C, D and E class, same as the binary notation, but the first byte will be different. Now this is again the same format of the dotted decimal notation as the binary notation, but the first byte will change of the IP address. So as we are discussing about the dotted notation, so whenever a IP is in the range, that means 0 to 127. So whenever IP is of range 0 to 127, that is of class A, and if it is in the range 128 to 191, that is of class B. And if the IP is of range from 192 to 223, that is of class C. And the range of class D is 224 to 239. And if the IP is of range 240 to 255, that is class E. So that is all about the classful addressing. So we have represented in the binary as well as the dotted decimal notation. So now we will discuss how to find out the class of any address. So first we will discuss about the numerical or the binary notation. So our question is to find out the class of address. So example, we are having a particular binary address. So that is our given IP address in the binary notation. Now we have to find out the particular class of the IP. Now we will find out the first byte. Now here is the first byte and this one is my first byte. As you can see, the IP is starting from 0. So that means it represents the class A. So the IP is of class A. Now again we have one more IP address. So let's take the example. So now we have given one more IP address that is in the binary form in the 0 and 1. So we will find out the first byte. So here the first byte, that means this one is my first byte. And as we know that the IP is starting from 110, that means the 110 is of class C. So now we can say that the IP is of class C. So that is all about the numericals on the binary notation of IPv4 address. Now we'll discuss about the dotted decimal notation. Now again we will find out the classes of each address. Now, for example, we are given a particular IP address which is in the form of decimal dotted notation. That is, for example, this is 14.23.120.8. So this is my given dotted decimal notation IP. So first of all, we will check the first byte. So our first byte is 14. So now 14 is the range of 0 to 127. 14 is greater than 0 and it is less than 127. So now it is in the range of class A. So that means this is the IP of class A. Now let's do one more numerical that is based on the dotted decimal notation. So let's do one more numerical that is based on dotted decimal notation. So that is 252.5.15.111. Now find out the IP addresses of which class. So we will first consider the first byte. Now the first byte is 252. Now this 252 comes into the range of 240 to 255. It is greater than 240 and is less than 255. So the range is 240 to 255. That means this is of class E. Now the next we will discuss in the IPv addressing is classes and blocks under classical addressing. So next we will discuss the classes and blocks under IPv4 classes. Well, as we know that the classes are A, B, C, D and E, but every class is divided into particular blocks. So let's draw a table to signify all the blocks, their block size and number of blocks and their particular applications. So first we have the classes, then we have the number of blocks, then we have the block size, and then we have the application. Now we are having 5 types of classes. This is class A, B, C, D and E. In the class A we have the number of blocks, that is 128, and its block size is 16777216. And its application we use it for unicast, that means one-to-one communication. Then we have a class B whose number of blocks is 16384 and the block size is 65536, and again its application is for unicast. Now the next we have the class C whose number of blocks are 2097152 and the block size is 256. And its again purpose is unicast. Now the next we have the class D, which is having a number of block is single one and the block size is 268435456. This is basically used for multicast. Now the last class E, that is again the number of block is 1 and the block size is same as the class D, that is 268435456, and that is reserved for the future use. Now we can see that we have the 3 main classes which are of use for unicast and 2 in which out of 1, that is class D is for multicast and class E is reserved for the future use. Now the class A, B, C, D and E have their own functions. Now if we are talking about the class A block address are too large for any organization, so addresses are wasted. So class A addresses are used for large organization. What do you mean by the large organization? A large organization, that means we have the various or large number of attached hosts as well as the routers. Now the next we have the class B. In the class B, that is used for the mid-sized organization. Now the class B block address is also too large for many organizations. Next we have the class C. Class C is used for small organization. Now again the class C block is very small for many organizations. So that means the class A, B, C IPs are unnecessary wasted and we are facing the problem of address depletion. Now about the class D block address are for multicasting and most IP are again wasted. Then we have the class E. In the class E we are reserved IPs, that is for future use. So the class E block are for future use but few are used and rest are wasted. So that means if you are talking about the classful addressing, class A, B, C, D, and E are the addresses but they are unnecessarily wasted. So that's why we are facing the problem of address depletion. So we have discussed the classes and blocks in the IP address classes. That means we are having the class A, B, C, D, and E, in which class A, B, and C are used for unicast, D for multicast, E for reserved. So that means class D and class E we are not going to use in our particular examples. We have taken only class A, B, and C for our use in the LAN as well as any local area network or any other network. So class A, B, and C are main focus. So now these three classes are further divided into net ID and host ID. So the next topic is net ID and host ID. Now in the classful addressing, classes A, B, and C are divided into net ID and host ID. So to understand how the IPs are divided into net ID and host ID, we are having a masking table. So we will draw a masking table with the help of the particular IPs can be divided into host ID and net ID. Now we are having a particular table in which we have the four fields. The first one is the class, second one is the binary. Now here binary stands for the binary notation of IP address classes. Then we have the decimal dotted notation of IP address. And the last one we are having the CIDR. CIDR stands for the class inter-domain routing. Now classes are of 5 types, class A, B, C, D, and E. But D and E classes are for special purpose, that is for multicasting and for the future use. That's why we are only taking the 3 classes, class A, B, and C. Now we'll start with our class A. In the class A, the CIDR is /A. And about the decimal dotted notation, we are having the IP address 255.0.0.0. And again we are having the same IP in the binary form, that is 8 times 1, then 8 times 0, again 8 times 0, again 0. Now you may confuse that, what is that /A? What is that CIDR? As we know that the complete IP is of 32-bit. Now the /8 means the first 8 will be the 1. That means these first 8 will be the 1. So these are the 8. So that is all about the CIDR, class inter-domain routing. That means the first 8 bits we have set as the 1, then rest are the 0. Now the first 8 bits is called the net ID and rest of the bit is called the host ID. Now first 8 are net ID and rest is our host ID. And the last one is my host ID. Same if we are using the decimal dotted notation in which the first octet is my net ID and rest 3 are the host ID. Now next we have the class B. In the class B there is the CDR is /16. That means the first 16 bits will be the 1 and rest are the zeros. And in the same case, if you are using the decimal dotted notation, we have the first 2 octets as the 255 and rest are the 0. So again the 1 is my net ID and 0 is our host ID. And if we are using the dotted decimal, the first 2 octets are the net ID and rest are the host ID. In the class C, we are having the CDR that is /24. That means the first 24 bits will be 1 and rest will be 0. And if you are using the dotted decimal and we are having the 3 octet as the 255 and rest will be 0. So our 3 first octets are the net ID and rest 1 octet is my host ID. So that is all about the masking table of net ID and host ID of class A, B and C. We call it as the default mask for classful addressing. So our next question is to find out the host ID and net ID of particular IP address. For example, we are having a particular IP that is 196.168.79.15, and we have to find out the net ID and host ID of this particular IP. Then first of all, we will find out from which class that IP address belongs. So this is my IPv4 address, and we will check out the first octet. And here the first octet is 196, and this 196 in the range of 192 to 223. So that means the range is 192 to 223, which represents that it is the class C IP address. So as in the class C, it is clearly mentioned that first three octets are the net ID and last one is the host ID. So our first three is the net ID and the last 15 is my host ID. So that is all about whenever we have to find out the net ID and host ID. First of all, check the first octet, then check out the table and find out the net ID and host ID of the binary as well as the dotted decimal notation. So that is all about the IP address and IP address classes of IPv4. Thank you.